All right, so powers of 10, scientific notation. What is it for? It's for writing very large or very small numbers using powers of 10. So my wedding band, I actually took it down to the science lab. I went and put it on a scale, and I found out that it was 2.3 grams. All right, assuming it's pure, solid gold, and most gold isn't completely 100% solid gold, let's assume that. I wanted to figure out how many gold atoms make up my gold ring. Now, you guys would have learned in science that everything's made up of atoms. It takes a whole lot to make up something. So I happen to know how to convert from grams to atoms. And so I set up a little conversion chart here. And I happen to know that the 1 mole of gold has 197 grams. That's a conversion factor, just like each foot has 12 inches. Every mole of gold has 197 grams. I looked it up. My grams divide out. I am now in moles of gold. But I want atoms of gold. And I happen to know how much a mole is. Like, if I say to you a dozen, you know it's 12. If I say a gross, do you know what a gross is? It's 144. Most people don't use it a lot anymore. But a gross is 144. A mole is 6.023 times 10 to the 23rd. That's a big number. That's a gigantic number. But that's the amount of mole. It's just like a dozen is 12. A mole is 6.023 times 10 to the 23rd. So now I'm out of moles and I'm into atoms. And if I take my calculator and I multiply 2.3 times 6.023 times 10 to the 23rd, and I divide by 197, I get this. 7.03, and this is a big round off, times 10 to the 21st gold atoms. 7.03 times 10 to the 21st gold atoms. Don't write this next thing. You can write that up there. Let me show you what that number is. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so right here is a million. This is a billion. This is a trillion. All right. So this is million, billion, 7 billion trillion atoms. It's big. 7 billion trillion atoms. 7 billion trillions. It's a lot. It's how many atoms of gold there are in that ring. Okay, it's a really big number. We want to write it with scientific notation, and hence powers of 10. All right, so if I'm going to help you to understand scientific notation, we got to understand our powers of 10. Let me get rid of my shade here, if I can get rid of it. Thank you. All right, so let's talk about powers of 10. If I wanted to write the number 10 with a power of 10, it would be 10 to the first power, right? Nothing earth-shattering there? 10 is 10 to the first power. 100 is 10 squared. 10 times 10 is 100, is it not? This is the whole basis of writing in powers of 10. 1,000 would be 10 cubed, or the third power. 10,000 is going to be 10 to the fourth power. Does anybody see a pattern? What's the pattern you see? Abigail? Whatever the exponent is, that's how many zeros. 100,000 is 10 to the fifth. A million is 10 to the sixth. I don't have tens of millions, but that would be 10 to the seventh. Hundreds of millions would be 10 to the eighth. Billions is 10 to the ninth. Right? I skipped 10 million and 100 million. Went to billion. I skipped tens of billion, that would be 10 to the 10th. Hundreds of billions, that would be 10 to the 11th. And trillion is 10 to the 12th. Etc., etc. You can keep going. So look, here's the key on numbers like this. Watch. What if I wanted to write, don't write this, just watch. What if I wanted to write the number 7,000? Isn't 7,000 7 times 1,000? Isn't it? So can I write it 7 times 10 to the third? Right? 7,000. It's just another way of writing the number. Okay, well, we could also get smaller than 1. So, 0.1 is 1/10. And don't write this, but 1/10 is the same as 1 over 10 to the first power, right? Yeah. What would happen if I put it in the top? The positive 1 exponent becomes a what? Negative 1. And this is 10 to the negative 1. 1/10 is the same as 10 to the negative 1. All right, remember negative exponents? Take them across the fraction bar, they become the opposite. Okay, so 0.01 is 10 to the negative 2. And 0.001 is 10 to the negative 3. And so forth and so on. So how does this one work with the zeros? John?
How big the exponent is how many zeros separate the point.
All right. Maybe that works in your mind, didn't help me out, but you're thinking at least. Raina?
Like for example, if it's -2, there's 2 numbers behind
All right, I'm just worried about zeros. How does it relate to the zeros? How does the exponent relate to the zeros? Mason?
Just how many numbers there are in general?
Nope, I'm telling you, related to just the zeros. Jocelyn? There is one less zero than the exponent, right? The exponent's 2, even though it's a negative 2, there's only 1 0. It's negative 3, instead of having 3 zeros, there's only 2 zeros. When it's negative 4, we don't have 4 zeros. How many zeros do we have? 3. Now again, that's an easy way of figuring things out. If that doesn't click in your brain, that's okay. If a billion is 10 to the 9th, a billionth is 10 to the negative 9. If a trillion is 10 to the 10th, a trillionth is 10 to the negative 12. All right, knowing your powers of 10 helps you to understand numbers. So let's get down to the nitty-gritty of converting. So how do you convert from standard notation to scientific notation? SCIENTIFIC. And I'm going to go out to the right here and put a parentheses, capital S, capital N. A lot of times we'll abbreviate capital S, capital N for guess what? Scientific notation, right? Okay. Don't worry about this chart. All this is to go back if perchance you're not sure what to do next. You're going to find that writing them is a whole lot easier. But I do want everything down in case you need something to go back to. All right. Write all non-zero digits and all zeros in between them. That won't mean much to you right now, and I'll show you what I mean in a minute. This next one's really important. The second one in green here. Place the decimal point after the first digit, always. The decimal point always goes after the first digit. You'll next write times 10. And this is about the only time we use an X anymore for multiplication. It does represent multiplication, and we usually use an X for proper scientific notation, not a raised dot. All right, this last thing is really how you get the exponent. The exponent will be the number of places the decimal point moved. The exponent will be the number of places the decimal point moved. So guess what? If you move the decimal point to the left, you'll have a positive exponent. These are for big numbers. So let me go back to my example here of 7,000. There's no decimal point shown right now, is there? But wouldn't it have been right there at the end of the number, right? And at the final answer, it's not shown either, but isn't it right there? We took it from here and we moved it there. We moved it to the left. And therefore, our exponent is positive because whenever you move it to the left, the number was bigger than 1. And that's what we're after. Numbers bigger than 1 have positive exponents. Numbers less than 1 means we got to move the decimal point to the right. They're going to have negative exponents. All right, so again, don't worry about the chart. Let's get down to how to do this, and you're going to find that this is pretty easy. So you guys have that at the top of your page to help you out. But here's how it goes. All right, we're going to convert. Let me use my shade here. Try to focus your attention. All right, so B, convert the following to scientific notation. All right, so our first number is 400 million. Can you read your numbers well, I hope? 400 million. All right, the first thing says, write all non-zero digits and any zeros that might be between them. Well, all we have is a 4. We have no other digits that aren't zeros, so there's nothing else to write but 4. That's it. There is nothing else. All right. Next it says, place the decimal point after the first digit, so we'll stick it there. We're not going to need it, but that's where it goes. You write times 10, and then we got to figure out the exponent. And all you got to do to figure out the exponent is figure out how many places the decimal point moved. Do you agree it's right there right now, right after that 4? It's not shown, but it would have started here. Agreed? And now you just got to count the spaces. So 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. And our final answer, we don't need the decimal point on a single number. 4 times 10 to the 8th. Here's all we did. We had to figure out that this is 4 times 100,000, and 100,000 is 10 to the 8th. And if you were to multiply 4 times 100,000, you get right back to our number, 400,000. It's another way to write it. And this becomes more important in science, again, when you get to things like how many atoms are in this ring. I mean, we definitely don't want to write a number with 21 places. It would take up half the paper. So scientific notation for writing really large and really small. Are we going to use really big numbers and really small to teach you? Not really, because we're just trying to teach you. So some of these numbers aren't all that big, although number 2, that's a pretty big number. This is what, negative 70,800,000, right? Negative 70,800,000, did I say 800,000? 800 million, right? Negative 70,800,000,000. Agreed? You know your places, I hope? If not, brush up on your places. Okay. So the first thing we want to do is we want to write all digits and any zeros between those digits. Now, this is a negative number, so not a problem. We're going to keep it negative. So somebody tell me, what do you think I write first off? Abigail? Negative 708, correct. And I just say the digits, I don't worry about, but yeah, negative 708. Abigail gave me the 2 digits, the negative 7 and the 8, and of course we need that 0 in between them. Okay, what's the next thing I want to do? Michael? And where do I put it? Not after the 8. Mason? After the 7, after the first digit. So really after the negative 7. Okay, your first digit is always between 1 and 9. Positive and negative doesn't matter. It's always got to be between 1 and 9 if you're going to be in proper scientific notation. All right, next thing we write is times 10. And why don't you figure out the exponent? What is the exponent going to be? Everybody figure out the exponent. I see some people writing, which is what I would have expected to see all people doing. All right, on 3, give me your answer. Just tell me the exponent, like 6, 9, 40, whatever you have, okay? On 3, 1, 2, 3.
7.
All kinds of different numbers I heard. All right? Now, here's what I expected to see, and I didn't see any of you doing it. Again, let's go back to the last thing. The exponent will be the number of places that the decimal point moved, and I didn't see hardly anybody moving the decimal point. So let me go ahead and move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Didn't it end up right there? Didn't it? So how can you get that wrong? I didn't see hardly any of you counting. That's how you figure out the exponent. It's a 10. Negative 7.08 times 10 to the 10th. How many of you actually literally did this to count? Yeah, a few of you. Guess what? Newsflash. I am your teacher. I am here to help you. All right? I'm here to teach you how to get the correct answer. But if you don't do what I'm showing you, then, and maybe you didn't, I didn't know to do that. Okay, that's why I did it here on the first one, right? Counted how far that decimal point moved. And these aren't hard. You're just counting, and we can all count. Figure out how far this point moved. All right, let's do the next one. Well, there's only one digit again. It's a 5. And usually when there's one digit, you don't need to write the decimal point. So we're just going to write the 5. Do you agree it's times 10 is next? And the last thing is we got to figure out the exponent. Is our exponent going to be positive or negative?
Negative.
How do you know it's going to be negative? Just say it if you know it. Just talk. Because I got to move it to the right for 1, and because the number is smaller than 1, isn't it? Any number smaller than 1 has to have a negative exponent to show that number. All right, so figure out what the exponent is. I'm going to use red. I always like to use red for my negative exponents. So I know it's going to be negative something. So negative what? Don't say anything yet. Figure it out. Alex, got it? Going to be right? You right last time? So when we do on 3, don't try to be over loud. Just be normal. This way I can hear everybody, and that's what I like. That gives me an idea of where you're at. All right, so on 3, I want you to tell me the answer. Here we go. 1, 2, 3.
Negative 6.
Okay, I heard negative 6 and I heard negative 7. I hope you agree the decimal point ends up after the 5, right? When it's not shown, that's where it ends up, so let's count. 1, 2, 3, 4, 5, 6, 7. That's the 7, all right? Negative 7, right? Just count. Just count. Just count. All right, I chose this next one on purpose. Again, it's negative, right? What's the first digit you come to? It's a
6.
Then you have an 8, and here's a special situation. Why do we bother to put that 0 there? Does it change the value? Because it ends to the right of the decimal point. 0.5 and 0.50, isn't that the same thing? But listen now. When you get to real life and physics, the reason the 0 is there is to show that this number is accurate all the way to that place, which is more accurate than being just to that place. So the 0 really has significance. So the special case is if a 0 ends a number to the right of the decimal point, you include them. So we need that 0. It's just an accuracy thing. Numerically, same value. Accuracy, more accurate. We want to keep the accuracy of the number. All right, where does the decimal point go? Somebody tell me where to put the decimal point. Ariana? After the negative 6. I agree. Then we write times 10. All right, figure out the exponent, guys. Remember, it's a negative exponent because we're moving to the right, not because the number's negative. It's a negative exponent because we're moving to the right. All right, on 3, give me your exponent. 1, 2, 3.
-6.
1, 2, 3, 4. Where did it end up? After the 6, right? Isn't it right here?
Oh, yeah.
You can't go past it. You got to go to where the decimal point ended up. Right? And hopefully you agree it ends up 4 places to the right. Abigail.
When writing your final answer, since the decimal point has everything after it, would you write it in the circle? When you circle your final answer, would you put the decimal?
No, so this is the actual final answer right there. Negative 6.80 times 10 to the negative 4th. That is the answer. Ariana.
So should we rewrite it like you did in the first one? So that
The only reason I rewrote the first one is we normally don't write a single number with its decimal point showing.
Oh.
That's the only reason we rewrote, because we usually don't do 4 decimal point. And again, that's what goofs up students. I don't see the decimal point. Well, we know it's there. It's just not written, right? Because we want to goof up students. That's what math is all about. Let's see if we can confuse our students. Okay, let's go the opposite direction. Now we got to go backwards. Now look, if you know your powers of 10, what is 8 times 10 to the 5th? 10 to the 5th is how much? Do you know your powers of 10? It's 100,000. So what's 8 times 100,000? 800,000. So your answer better have something around 800,000 in it, if you know. But look, all you do is everything in reverse. So this is normally the way I do them. Oh, I hate when it keeps flipping on me. All right, do the 8.102. I want my number to get bigger, correct? So I'm going to move the decimal point how many places? How did you know to move it 5? Because that's the exponent. And 5, do I go right or left? What's going to make the number bigger? Right, so I'm going to go right. 1, 2, 3. Oh, I need a 0 placeholder. 4. I need another 0 placeholder. 5. And there it ends up right there. Do you agree? Right, I moved it 5 places. Now let me rewrite the number with the proper commas, right? And by the way, whenever your number is over 1,000, you need to use your commas so the person can read your number accurately. 810,200. Ah, we were in the 800,000 range, weren't we? Because we understand our powers of 10, right? Our answer makes sense. I'm going to talk to you guys a lot about the MAMs. Does my answer make sense? All right, and hopefully it does. So the second one, 10 to the 8th. 10 to the 6th is a million. 10 to the 8th has to be then 100 million. So we better be around 4-something million. Well, same procedure, right? 4.6. And start counting. 1, need a 0. 2, need a 0. 3, need a 0. 4, need a 0. 5, need a 0. 6, need a 0. 7, need a 0. 8. All right, that's the 8th. And I can go back and check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 8 places. Now, I don't know about you on this one. Sometimes I need to work from the back to get my commas in the right place, right? And look at that, 460 million. Beautiful for spacious skies. For amber waves of grain. Oh man, we got a number 3 to finish off yet. I better roll here. All right, real fast. Be careful going the opposite direction. So watch. Go 8 and then put your decimal point. When you see a negative exponent, what are you expecting? A small number, right? Therefore, I'm going to move my decimal point left. So watch. That's 1, correct? I need a 0 placeholder to be able to go 2. I need another 0 placeholder to be able to go 3. And I need a last 0 placeholder to go the 4th. 0.0008. By the way, notice how many zeros we had and notice what the exponent was. Remember what I talked about in the beginning? One less zero than the exponent. I see a shortcut. Do you see a shortcut?
No,
I do.
I don't see.
One less zero than the power. Right?
Oh, yeah.
3 zeros in front for a -4. If it was -7, there would be how many zeros in front? 6. So here we got a -3. How many zeros in front?
2.
So watch. Negative sign. Decimal point are 2 zeros. And then what do I write next? 260. There we go. Little shortcut there on the negative exponents, which, by the way, is safer. Because sometimes when you count, you get them wrong for some reason. I don't know why. So that shortcut helps. All right, I got to do these last couple things. So hang in there. I've been doing good getting you out for lunch, but not going to happen today. Okay, put the following in proper scientific notation. This is a really important concept. Notice it already has a power of 10. But the first digit, it's not 3 point something, it's 38 point something. That's wrong. I needed to be 3.82. I had to move my decimal point. Now watch. Did my front number get smaller or bigger? Smaller. If this got smaller, you have to make this bigger. So therefore, it's going to be times 10 to the 15th. If I make it 1 smaller, I make the exponent 1 bigger. Let's do C next underneath of it. I've got to make this 2 smaller. Agreed? So therefore, I need the exponent to be 2 bigger. Now be careful, it's a negative exponent. What's 2 bigger than -5? Michael? -3, right? -5, -4, -3 is 2 bigger, right? Catch that? 2 smaller, 2 bigger. All right, this one has to be an 8. Look what I just did. 1, 2, 3. I just made it 3 bigger. What do I do to the exponent? I got to go 3 smaller. Be careful. This one's tricky. What is 3 smaller than a -1? Madison? I'm sorry, then a +1 would be a -2, right? +1, 0, -1, -2? Does that make sense? All right, last one. 1, 2, 3, 4. Right? Because it's got to be 8.4. I moved it 4. I made it 4 bigger. What's 10 to the -9th? 4 smaller. -9, -10, -11, -12, -13, right? All right, practice tonight. You are dismissed. Oh, yes.
Oh, yeah.